Hey all, welcome back to Intro to Android Development. My name is Joe Fulgeri, and I'll be giving a guest lecture this week on persistent storage. So persistent storage is basically storing information after the app is closed. So this is really useful, and pretty much all apps you use make use of this to some extent. So some examples of information that we might want to store are things like favorites or different in-app settings. Other things could include login information or more complex data, like, for example, storing images on Snapchat or in a to-do app, storing all your different tasks and stuff like that. In general, there are two ways that are most commonly used to store data like this persistently. The first one is shared preferences. Now, this is for storing a lot more simple data, generally storing user preferences. And this is structured as a key value store, like as a dictionary or a hash map or stuff of that general flavor. And throughout the app, you can have many different shared preferences files. So if you have a lot of different preferences for different parts of the app, or just more complex reasons to want to segment stuff like that, as we'll see in the demo, you can do that. The second way to store data is through rooms, and this is an abstraction around the underlying SQL database that Android uses to store this data. So this is for more structured data. So for example, for actual classes or objects, not just primitive strings or ints or stuff. The three main components to these are entities, data access objects, and the actual database itself. So entities, for those of you who are familiar with actual databases, represent tables. But in general, an entity just represents the actual object or class that you want to store. Data access objects, on the other hand, are an interface to provide interactions with the database. So for example, the data access objects define how you can insert objects into the database, retrieve objects from it, update objects in the database, or delete certain objects from the database. And then the database itself is just an abstraction tying together the entities and the data access objects. Now we'll see in the demo how we can use all this to actually store data and use this in our apps and hopefully in your final projects. We'll be demonstrating shared preferences, which, as you recall from the lecture, is just a simple key value store to store simple things like user preferences, login info, or other smaller pieces of data persistently. So set up a skeleton of an app. So for the first part, we'll just be working with this top part. So the goal here is we'll enter some value, preferably, or which would represent like some preference or something. And then we hit the Save Preference button. It'll save that to persistent storage. So that when we close the app and then reopen it, this field will be populated with whatever we had saved previously. So we'll first start in the code with that preference buttons on Click Listener. So in that block is exactly where we're going to want to save that preference. So we start out by getting our shared preferences file. Um, so, oops, we first need to get the context, and then from there we can just do get shared preferences. So now this takes in two parameters. The first one is basically the name of the specific shared preferences file that we want to reference. So as you recall, we can have any number of preferences files for a given app. And this could be useful just for organizing how you store your data and other stuff. And each one will have a unique key or name here. So we'll just arbitrarily just call this, I don't know, file key. It's just important that when you want to get the same value out and get that same shared preferences, use the same key. Now the second parameter is basically like an access parameter, so it can define if, for example, you want other apps to be able to access these preferences. But in most cases, you don't. You want to keep your data private, so use context.mode private. So from there, setting the preference is actually quite easy. It's preferences, edit, and then put string in this case. You have other options for other data types you might want to store, but in this case, we want to store a string. So the first value is the key, um, and if you recall, the preferences are basically a key value store. So you can have the key be whatever you want. You just need that same key to retrieve this value whenever we want to retrieve it. So I'll just put, value key. Ideally, you want some better naming scheme, but in this case, it's pretty trivial. And then the second argument is just the actual string you want to store. So we'll want to get the preferences text, get the actual text from it, and call it to string. Now there's one last step here, so we have to actually commit these changes. So we can just simply put preferences dot, or, oh wait, we have to do it, we have to chain it on the side. So we just do dot commit there, and that'll actually commit the preferences and save them. However, there's really not much to demonstrate here so far, since we're not actually retrieving them, we're just saving them, and there's no real visuals associated with that. So in this case, so now we want to actually retrieve it. So it's pretty similar. We access the file again in the exact same way. And it's important we're using that same key. So now to actually get the text, first let me create a variable for it. So we get that same preferences, and then we simply just do get string. And the first value here is going to be that same key that we used before. So if we used a different value, we just wouldn't get anything out. And then the second here is the default value. So in the case that there's no corresponding value for this key here, this is what's going to be returned. So I'll just put an empty string for that now. So now it's important to note that when we run this next, since nothing will be saved, we will get that empty string back. So now let's set the edit text to actually be the string so that we can see it. Awesome. So now let's try this out. So we'll just save something. Awesome. And we'll close out the app and restart it. And there it comes back, something. Awesome. So if you needed to save favorites or some other data, this is how you can do it. Oh, we're going to be storing a little bit more complex data. We basically have a list of grocery items that we want to store. So for the sake of having easier UI and demo, we're only just storing the name of the grocery item and the number of items. But if this were a lot more advanced, you could be storing things such as photos, links to descriptions, brands, prices, a whole bunch of different attributes. So basically, we'll want to enter something, enter the number of items and hit save. And when we hit save, we want it not only to populate this list view here, but we want to save it persistently so that when we close the app and reopen it, we'll have our grocery items so that the app is actually relatively useful. So the first thing we need to do is add in some dependencies into your project's app and project build.gradle. So if you can go to the textbook, most of it will be there, and it'll be easier just to copy right from there. So since we're using Java, we only need these four. If we were using Kotlin, we'd need these other two as well. But you can copy those and plop them right into your dependencies. And then in addition, you need to add this into your project's build.gradle like such. And then you'll want to sync. Files are synced. We'll want to begin by creating a new entity. So this is basically going to represent one grocery item. So we'll create a new Java class for this. We'll call it grocery item entity. Pretty straightforward. And we will get started. So first we'll want to mark this with an @entity. um, tag. And then from there, we'll first want to do create our primary key. Um, every entity needs a primary key, and this is something that needs to be unique across all entities. So here in this case, we'll make the item name unique. So in this case, our grocery items are going to all have to have different names. And then from there, we can add columns, which are basically just other fields. So the only other field we have is just the number. So column info number. And from here, we can then continue by creating our data access object. So we'll call this grocery item DAO for data access object. It's a common abbreviation. For the sake of time, I'm going to cheat a little bit by copying some of my code from the textbook. But I'll walk through this in just a second. Well, actually, first, we'll just want to mark this as a DAO with that annotation, and it's actually an interface, not a class. So I'll plop that in and import everything as necessary. So basically, as I said before, the DAO is just a means of interacting with the database. So basically, each of these is just a way to get stuff or set stuff from the database. So for example, here we are getting all of the items from the database. Or here we're getting some subset of the items from the database, where it takes in this argument, a string list of the item names, and we try to find those ones. Maybe that should actually be item name, because they use a different scheme. Then again, you can insert, update, or delete. And you can make a lot more complex queries or insertions or other stuff using SQL. However, a lot of the very simple ones, or a lot of the functionality can be done very simply with just, querying like that, inserting, or deleting. In general, if you have a specific data need, it's pretty easy to Google and find an appropriate SQL query. So from there, we actually just need to make the database object. So we can begin by, again, creating another database, another class. We'll call this grocery database. And again, as before, we mark it with an @database. Annotation here will take in a couple things. So first we need to set the entities. In this case, we only have the one entity. So we can just put that in there. So this basically says that this database will be storing this given entity. And then the second thing we need to pass in is the version number. By and large, you can ignore this for the most part. This is mostly used when you're making really large changes to your database, like structural changes, for example, changing which entities you're storing, or stuff like that. So this version number allows you to control that in a more fine-grained way. However, that's outside the scope of this lecture, but you can Google that somewhat easily. So here the actual class is going to be an abstract class, which I spelled wrong, and it will extend the rooms database, or room database class. We just need to add in the actual DAO to show that that this database will implement that. And that is pretty much most of the overhead we need. Now we can go back to our main activity and actually start working with this. So right here is where we're going to want to retrieve our groceries to set that to the string list that the adapter feeds from. So we'll want to begin with retrieving the actual database object. So it's a class grocery database. So you use room.database builder and takes in a couple arguments. First, the context, so get application context. It takes in the class itself. Whoops. And then it takes in a name for the database. And this could be any arbitrary name, because as before, this is a specific name that we're giving it. So when we want to access the database again, we have to use that same name. So I'll just call this grocery database. And what am I missing there? And then you need to actually call the build function on the end. Forgot about that. And then from there, it is pretty simple. You can just do database.groceryitem.dow. And then from there, you have access to all those functions you defined in the DAO. So here, we want the get all, which will return, as we saw before, a list of database or of grocery item entities. So we'll define a variable for that. Now, it's important, one thing that we need to do is we can't run this on the UI thread because the database is acting or is working with the phone's internal storage, not just the memory. So accessing that takes a hell of a lot longer than just the memory. And because of that, it can block the main thread if you're running this on the main thread. And this would cause the UI to basically freeze or become really slow, which is never a good thing. So actually, Android won't even allow you to do that. It'll throw an error if you try to just access it here like that. So we need a new async task here. So as I believe you learned in the networking lecture, you could just do this by async task.execute and then need a new runnable. And basically, it'll run in the background everything in this run function. So we could just plop that in there. And then because this array list is actually a string list, we'll just need to convert these entities to strings. Want to loop through all the entities and convert them to strings so that we can actually display them just using our simplest adapter. So here, just a simple loop. And then actually we will want to move all this code up here so we can access this from this block that we're in. So here we'll just want to do groceries.add, and then so I want to get the entity at that location, take the item name, we'll add in a colon and a space between that and the item number. Awesome. So then from there, we do still need to notify the adapter that our dataset has changed. However, since we are in an async task, we need to run this from the UI thread. So just like we did from the async task, we could do the same except in the other direction. So new runnable, and then adapter.notify dataset changed. Awesome. And one other change that we needed to add was we needed to say that this item name is non-null, because obviously this primary key, since it needs to be unique, it can't just be null. So from there, let's test that out. So we'll add stuff. We want a lot of stuff. Okay, now it's saved. So swipe up, restart the app, and lo and behold, it is not there. I forgot a step. We didn't actually save the grocery items, we only retrieved them. So yeah, not too helpful to retrieve nothing. So yeah, pretty similar to here, to above. Need an async task, because we don't want to run this from the UI thread. We don't want to block anything. So grocery database db equals room dot database builder. Put in the context. Put in the class, and we will put in that grocery db. Hopefully I spelled that properly. Then dot build. So again, simply grocery item DAO dot insert. And then actually I think we will need to give the grocery item entity an initializer. So public. Awesome. So now we can initialize our entity in here to pass it in. So we can just use these edit texts to get the appropriate stuff. Get text to string, and then number edit text get text to adding the item into the database, just parsing it improperly. So just to recap, we have inserted the item into the database. When we click that button, the insert item button, and when we initially open the app, we retrieve all the grocery items from the database. So let's try this out. Alright, so we have our item there. Let's go away and come back. Dun, 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 and it's there. Awesome. So that is a general overview on how to use rooms to store some more complex data. So again, if we go back here, you can add, any arbitrary amount of columns, and it's generally just a more clean solution. Because once you're storing objects, while it's possible to use shared preferences, it becomes hacky really quick and is really just not a good convention. And the more complex your objects get, the more issues that it can cause. Yeah, thank you for watching. I hope it was not too jumpy, and yeah, have a great week.